and welcome to today's lesson. We are continuing on kinetic energy, and this time around we are going to look at some of the calculations that are involved in kinetic energy. I'm sure you saw the formula that I gave, the formula that we'll be using for kinetic energy. So this one will be quite simple to work out. We are told to say 2 kg stone is thrown. It was thrown at a speed of 5 meters per second. Calculate its kinetic energy. So they are looking for kinetic energy. Our solution will be, so our data in this way will be, what else are we given? We have got a mass. Then what else is given? We have got the speed, which we can call velocity, then which is 5 meters per second. What are they calculating for? Kinetic energy. That is Ke. Yeah, so finally we can use kinetic energy as half mv squared. Please write the correct formula when you are doing this. If you don't write the correct formula, it will be very difficult for you to get the answer. Not even difficult, it will be impossible to get the correct answer. So it will be half, you multiply by a kg, which is 2 kg, that is mass, you multiply by its mass, then you multiply by the velocity, which is 5 meters per second. Don't forget to square it. So I'll write that there on top, and then that will be half times 2 kg times 5 meters per second, everything squared. So this and that will cancel. You won't remain with a kg times 5 squared is 25, then meter squared per second squared. And that's a one times that will give us a 25 kg meter per second squared, which is equivalent to a joule. So we can therefore say our kinetic energy is equal to 25. This is equivalent to a joule, which is 25 joules. So remember to write the correct units at the end of your calculations. Then question number 2. Question number 2 says a 60 kg people run 600 meters uniformly for 1 minute. So calculate the velocity. Calculate velocity. Calculate kinetic energy. Okay, supposed to be calculate velocity of the pupil. And then we calculate the kinetic energy gained. Okay, so we are going to calculate. We know that velocity, in this case we don't know the acceleration and the like, but we know that velocity is the change in displacement, distance in a, so it is the change that is displacement over time. So the change in displacement over change in time. And we are told that this one was actually moving uniformly. So that was 600 meters. You divide by the time given, which is 1 minute. But remember, 1 minute is in the wrong units. We learned how to convert our time as well. So 1 minute is equal to 60 seconds. So instead of writing 1 minute here, you write 60 seconds. And then you cancel out 6 there. It is actually a 10 meter per second. So that was our velocity of this body. So the velocity is done. That is our A. And then we have to calculate kinetic energy. Our kinetic energy will be equal to half mv squared. And then that formula must be mastered. You've got to know it. And then we have half. Then you multiply by the mass of an object. The mass was a 60 kg. This child was great, was heavy. 60 kg is a huge person, should be a very huge person. 60 kg you multiply by mv squared, which we have calculated as 10 meter per second square, meter per second, and then this, since it is squared, then that is a 2, there, that is a 30. We have a 30 kg, you multiply by 10 squared is 100, then meter squared over second squared. Okay, so 30 by that will give us 3000 kg meter squared per second squared. The whole of that is a joule. The whole of that is a joule, so we have 3000 joules as the kinetic energy gained by this running and hard working QP. We have come to the end of kinetic energy. Next time we'll look at how energy is conserved. Thank you and bye for now.